So this is my E8, I think it's the 3000 autogate system. It was installed 12 years ago. I did it myself. And what I did basically was I bolted this anchor in with plates on the outside. I'll show you a picture of that. But basically, typically autogate welders or autogate installers weld this to the member and it sometimes breaks here, initiates rust, etc. So what I did was I bolted it to this member and that would be a better solution to resolve the forces. Over here, so I made sure that this is on the member and fully mounted on the face. And that would make this arm, if I were just to slot this into here, it would make this thing not horizontal. So basically what I did was I used a bunch of spacers and lowered this bracket. So now that this arm is horizontal, it resolves the forces well, and there's no torsion on this point and all that. The other thing I did was I used the box. All my entries are glanded, including on the control box on the other side of this pillar. So there's a lower chance of water ingress. We'll be opening this for the first time in 12 years. We'll see how that held up. So, and one more thing I did was I increased the length of this. So I'm not sure whether you can see the welding here. I added this much extra material so that when the gate opens up, this um, creates a wider triangle so that the force that is applied on here when it tries to close is less in line with the hinges. So it has more of a, what is that? The vector is resolved more away from the hinge. And that has the benefit of reducing load on the hinge. And if you see, sometimes they install that barrel type hinges, the cylindrical ones over there, the welding oftentimes breaks. So what all I did was I just installed two nylon washers here so that they can slide when it sits. But hinges typically don't have vertical load. The bottom hinge has load this way, and the top hinge has load this way because the whole gate is trying to fall over, if you can imagine that. So all these things have to do is just take tension load, and up there it takes compressive load. Sorry, the top one takes tension load and the bottom one takes compressive load. That's all it needs to take. So you don't need to change your hinges. You can see after 12 years of daily use, multiple times a day, there's no real issue here. The hinges have, no, sorry, the arms have worked well. And oddly enough, this is the one that does not open all the time. This is the double leaf opening. The other one is the single leaf opening. So that one is used a lot more. Yet this is the one that failed, and I'll show you what happens now. So if I've already removed this screw, this bolt, and if I open it, can you hear that? The motor is slipping. See? So normally the motor should stop because on the current sensor, right? So I actually have to press the button to stop it. Come on, stop. I think it's timing out now, I'm not sure. Okay, and if I bring it in, okay. So there's a couple of things here. One is the piece that slides on the screw here, and there's another one that transfers the motor into the screw, the motor torque into the screw. It's like a coupling. So we have to take this arm out to see what's inside. It's quite straightforward. You open this one up, and the Bolts can be very rusty. Let's zoom in there. So you can spray W40 if you want to try, but W40 doesn't work that well. What you need to get is something like this. It's called penetrating oil. It actually is designed to soak in between the threads and break up the bond or the jam between the nuts and the bolts. So this is from Mr. DIY, not too expensive. You can get any brand you want. Some work better than others, but they all work better than WD-40. And get yourself a nice Allen key. Mine's an M8, I think. No, this is an M10. And go at it. So this is an M8. No, I think I'm supposed to use an M10. Yep, I brought the wrong one. Mine's an M8. I'll be right back. So I've not done this before. All I did is soak it with liquid liquid wrench penetrating oil, and it opens up. Before this, it was totally jammed. So look at this. It is opened. It's not at the bottom there. I'll look at it and I'll bring it back once I've taken this off, and we'll have a look inside here. Okay, so just use a common flat screwdriver to open this up. And this is the first time in 12 years that this is opening up. And oh man, it's jammed. I'm gonna put it away for a second. I got a couple of these lever tools. They're normally for cars, but let's see if they help. Oh man, I basically I don't want to force it because I don't want to break this cover. It'll be a pain in the butt to have to go out and get another one if I don't have to. So I'm gonna look at this and I'll bring it back. So this is the inside of the box, 100% bone dry. It looks like the plastic fused with the rubber gasket. I think I can reuse the backing. I didn't break that much. This one I kind of broke trying to lever it out, but it really fused in there. So now all I need to do is clean this edge up a little bit. If it's gonna rain, I better probably put some bag or something over this because I don't want any water to get in there. But my screws, I basically put silicone on the back and then smashed it into the wall and then screwed it up. So the water would not come in through here and into here, the box. Excellent. Worked out way better than I expected. Yeah, so I'm going to get this out, take it out from here, and then we'll remove the arm and look at what's broken. So if you're ever installing it yourself, you can see here, it's there are two cams, but I always bend my wires back and screw onto the insulation so it forms a good, tight, solid connection rather than the screw smashing the copper and basically snapping it. And then when you run the cable, always have a loop here which is just above the ground as long as you can. So that gives you as much flexibility in the wire as possible to bend and flex as it goes. So I'll take this out now and we'll see what happens. Always remember in this gland, there's a little rubber sleeve that's meant to compress into the sheathing to create a seal. So it's basically nut, rubber sleeve, slots into here, then you tighten it up, and this one will compress and become like a ratchet system to hold the nut close, gland close. I just put the rubber back and just slightly tighten this on so it doesn't run away, and we'll just leave this here. Oh, and the other thing, the rubber's supposed to go inside here if I'm not mistaken, so you'll have to like tuck it in when you're retightening it. Or maybe I'll just put it inside the box. That works too. Okay. So now to remove this, basically you just lift this thing out and this whole thing will come out. Decent after all these years. And keep this aside. There we go. It is a little bit heavy, but so now there's three screws to be opened here, which are Phillips screws. 1, 2, 3, and these screws go all the way through. So the other thing is, before you just take it out, just note that the bottom where the wire is lines up with the drain hole, lines up with the rivet. This is also a drain hole. Do not close this. So any water that gets, and you can see a lot of water has dripped out from here. So it's doing its job. And this rivet holds this assembly together. So we're just going to get a Phillips screwdriver and take this thing apart. Okay, so bring this in. When you're unscrewing this, make sure you push really hard inwards, otherwise you're going to spin these things out. And go at it slow. The moment you feel it rotate a little bit like that, it's going to jam up again. Give it a little bit of a tightening action, give it a jerk, and then slowly remove it. So let's remove all three of this. It's the same thing. These are long screws that go all the way until here. So remove all three. Oh, shucks. Jump the gun on this. Let's remove. All right, so I decided to come apart first, but I prefer to get the screws out. Let me just. All right, and last one. Well, it's coming apart. So you can see here, that's the motor inside there. And there's an O-ring set here. So I'm going to try and get this out. Then you can just guide the wire out through this hole all the way until light's in a bad direction, but I hope you guys can see this. Maybe I can increase the brightness. If I work, remove this. Let's do that. And solid aluminium. And this one, you basically slide out, but the motor seems to be coming undone. Slide this out. And there's a rubber support inside here, which okay. So if you look at this, it has three holes. And that's where the screws go in. So you can take that out, and the motor comes out. Well, and as you can see here, as I suspected, not sure you can see that. Let's brighten it up. This has spun out. So this is the one that converts the motor's rectangle drive to the rotational force of the screw. So now we're going to have to drill this out to get at this piece. It's going to get a drill and right back. This thing uses a rectangular drive. Let's see if we can get the motor out. The edges are sharp, by the way, razor sharp, so just be careful there. So now I'm going to drill this rivet out and we'll have a look inside. If you're wondering what's a good rule of thumb, get a high-speed steel drill bit that's roughly half or a little bit more than half the diameter of the rivet head. Basically, you want to cut off the head so you can reach the shank. Oh gosh. That's it. Let's come off. Be very careful when you touch these things. They can be sharp. Then it's almost perfect. It's the diameter of the shank. Get it out. And we're through. Try not to let the loose bit go through. Get it out. This is screwed on. I'm not sure. Well, sometimes, yeah. This is screwed on, so just undo it. And that's your mechanism. And this is what you want to make sure comes out. So we open that up. And that's the piece that we want to get at. We'll look at it in a minute, but this is your bearing. This is the thing that drives it. Slots into there. And this is basically a spacer centralizer. And this is the arm that extends. Oh gosh, the screw. And this still feels smooth and well greased. So I'm going to leave it as is. And this is the pin that stops it. You can see there. So it reaches the end. That's what stops it. So I should put this pin back in position. And it'll stay there. This has come out. So the reason why I suspected the other piece has gone is when I tried to turn on or open the gate or close the gate, and you could hear the thing skipping, right? Once I disconnected this side and I assisted it to come out and go in, it actually turned. So basically, as long as the motor didn't have to transfer a lot of torque into the system, it could turn it. As you saw, the plastic had spun out from the drive. So as long as that spun out plastic did not have to transfer torque, it could guide this thing out. And that would mean this gearing system here is still good. So all we need to do is change that. And I think this is like 20 or 30 bucks. The whole arm cost, I think it's 200 bucks. And I think I bought the whole system last time for, geez, 900, less than 1,000. And I did the whole install myself. So this is what you're going for. It just sits in there like that, and it rotates. And this is the part that spun out. It's a common failure point. If the screw had failed, I probably would just change the whole arm. But for now, the other thing is, some people sell this as solid metal. I would say still stick with the plastic because this is a failure point. You do not want to wreck the screw mechanism in there, which is way more expensive. If something jams and I want something to fail, I want the coupling to fail, the cheapest part. So I'm just going to measure this thing up, go on Shopee or wherever and purchase a replacement. I'll throw up a picture of what they call it. I have no idea. I'm going to take a photo and search it up. And I guess we'll be installing it once we get the spare parts. Oh, and one more thing. If you can, reassemble everything so that everything stays together in one piece and doesn't get lost or walk away or whatever while waiting for stuff to arrive. That's what I'm going to do. I'm going to tidy up. I have put a bag over the box and the gate over there so that rain doesn't get in. I've taped it up nicely and hopefully that preserves everything until I get the spare parts. So this is known as the arm coupling. So if you just check on Shopee, look for the E8 arm coupling. I'll throw it up.
So just type E8 autogate arm coupling. There you go. And these things should pop up. And this is an example of the allegedly upgraded metal coupling, the one on the right. Don't get that. As I mentioned, if you want something to fail, you want the cheapest thing to fail. And this is 30 bucks. I think these are PVC with an aluminium ring. It's basically a cut aluminium pipe. Yeah, so you can get them for about 17, less than 20 ringgit a piece. And when you're buying it, just be careful. There's two types that are very similar. The one on the left is the E8 arm, and the one on the right is the OAE arm. You can see the slotted keyway is slightly different. And if you look at the E8, the slot that goes into the motor is flush with the surface. For the OAE, the slot is countersunk with some holes there, but the main point is countersunk, so don't get this. Get this. This is what you need. It's 17 bucks. I'll probably get two because I'm guessing the other arm will die very soon. And I'll just toss it in the box and change it out when it's done. So easy fix, and we should get it very soon. And we'll continue this video when the material arrives.